Hello everyone, this is chapter 1 of mechanics. Today we will go over first part of the chapter 1, which include the measurement and uncertainty, and part of the part 1 significant figures will be also included in our discussion, and the unit standard and SI system will be also described in part of this chapter 1, and some of basic dimensions and the units will be also discussed in this part. Okay, so what you see here is image taken by NASA astronaut Neil Armstrong, and when he stepped his foot on the moon, this image was taken. So this view from the Apollo 11 spacecraft shows the Earth rising above the moon's horizon. The lunar terrain pictures is the area of the Seamus Sea on the near side. Coordinates of the center of the terrain are 85 degrees east longitude and 3 degrees north latitude. While astronaut Neil Armstrong, commander, and Edwin Aldrin, the lunar module pilot, descended in the lunar module Eagle to explore the Sea of Tranquility region of Moon, astronaut Michael Collins, command module pilot, remained with the command and service module Columbia in the lunar orbit. The sky appears black from out in the space because there are so few molecules to reflect light. Why the sky appears blue to us on the Earth has to do with the scattering of the light by molecules of the atmosphere. We will learn why the sky looks blue on Earth but dark in the Moon sometime in this course, and we will revisit this subject, this topic sometime in the last of this course. So let's move on. Measurement is the most integral part of the physics and also most fundamental act of science. Most observation in physics starts from the measurement, and the proof of theories is surely based on the measured data. Ideally, measurement is accurate and exact, but in reality, no measurement is exact. There's always some uncertainty due to the limited instrument accuracy and the difficulty reading the result. The uncertainty can be seen with this ruler. Well, it would be difficult to measure the width of this broad board more accurately than plus minus 1 millimeter. The estimated uncertainty is written with the plus minus sign. For example, 8.8 plus minus 0.1 centimeter. Percent uncertainty is the ratio of the uncertainty to the measured value multiplied by 100. Measurement always creates numbers, and the way of expressing numbers represent accuracy of the measurement and also scientifically important part of the number. The number of significant figure is the number of reliably known digits in a number. It is usually possible to tell the number of significant figures by the way the number is written. For example, 23.21 centimeter has how many significant figures? The answer is 4. 0.062 centimeter has how many significant figures? The answer is 2, because the initial zeros don't count. How about 80 kilometer? 80 kilometer is a little bit ambiguous. It could have 1 or 2 significant figures. If it has 3, it should be written 80.8 kilometer. Measurement leads to the data analysis, and in many cases, it includes a mathematical process such as multiplying, dividing, adding, subtracting. Significant figures should be taken into account in the process. When multiplying or dividing numbers, the result has as many significant figures as the number used in the calculation with the fewest significant figures. For example, 11.3 centimeter times 6.8 centimeter should be 77 centimeter. Calculators are very often used when handling with the measured numbers with the mathematical formulas. You should probably think calculators give you a correct answer. They can give you the most accurate numbers, but not the right numbers. Calculators will not give you the right number of significant figures. They usually give too many, but sometimes give too few, especially if they're trailing zeros after decimal point. Well, now you see the two calculators. These two calculators show the wrong numbers of significant figures. The one on the left hand side shows the answer of 2.0 divided by 3.0. The correct final result would be 0.67. In the one right hand side, the calculator shows 2.5 multiplied by 3.2. The answer would be 8.0. So depending on how you justify number of significant figures, that answer could be 3 decimal point or 2 decimal point. So the calculators not always give the right answer, but their number always just to very close to the correct answer. This is accurate, but not always correct. The other example is protractor. Protractor normally used to measure the angle of two lines. So using the protractor, you measure the angle. As you can see in this figure, two lines, red lines indicate an angle of 30 degrees. How many significant figures should you quote in this measurement? Use your calculator to find the cosine of angle you measure. So answer would be like this. If you look at the protractor, you will see that the precision with which you can measure angle is about 1 degree, certainly not on the 0.1 degree. So you can quote two significant figures, namely 30 degree, not 30.0 degree. If you enter the cosine 30 degree in your calculator, you will get a number like 0.866025403. However, the angle you enter is known only to two significant figures, so its cosine is correctly given by 0.87. You must round your answer to two significant figures. Speaking of the measurement and uncertainty regarding the significant figures, scientific notation is commonly used in physics. It allows the number of significant figures to be clearly shown. For example, we cannot tell how many significant figures the number 36,900 has. However, if we write 3.69 times 10 to the 4, we know it has 3. If we write 3.69 times 10 to the 3.690 times 10 to the 4, it has 4 significant figures. The much of physics involves approximation. This can affect the precision of measurement also. So there are a few ways to clearly justify basic physical quantities. There are only 3 quantities justified in physics, which is the length, time, and mass, and their unit is meter, second, kilogram. 1 meter is defined by the length of the path traveled by light in the 1 over 972,458 seconds. 1 second is time required for 9,192,631,772 periods of radiation emitted by the cesium atoms. 1 kilogram is Platinum Cylinder in International Bureau of Weights and Measures in Paris. So we will go through the last of this chapter with a few tables and a few examples how those lengths, time, and mass are justified with a few other examples. But now let's wrap up the part 1 and we will revisit this chapter and then look through the tables of examples for each of physical quantities. Okay everybody, thank you for watching this video and I'll see you next video.